Assalamualaikum. Hello everyone. So in this video, we're gonna basically try to summarize our discussion on definite integral and try to relate it with the concept of indefinite integral that we have discussed previously. Okay, so let me get the slides on. Okay, so what we're going to discuss today would be the fundamental theorem of calculus. Okay, so we're gonna so what we have discussed so far would be on the, with regard to the definite integral. We know that if we have a function, okay, on the f within the interval a and b, so the definite integral basically is the number of the corresponding area between the graph f and the x-axis, right? I mean, if this is our a and b, so this is our x. So whatever the so if we have this is our f of x, so this would be the what the definite integral, okay, is correspond to this area between the function and the x-axis. While the indefinite integral basically going to give us a family of the antiderivative. Okay, so we're going to basically try to see the relationship between these two integrals. We're going to use this example of cos function. So let's say we have a cos function which is given to us, okay, 180x plus 200. I mean, you should already know that this 200 would be fixed cost, 180 is the variable cost, x is the quantity, and the company also have face the technological constraint. I mean, the quantity can only be produced from 0 to 20. Now, this is the graph, right? I mean, from 200, so this is the y-intercept, and the change, okay, so let's say um, the change in from 5 to 10, which is the slope is 900, right? Sorry, the slope is 180, but if we were to change per unit, so if this change is 5, so from the cost of producing 10 units and the cost of producing 5 units, the difference between the two is 900. Okay, 900. So the marginal cost is 180. 180 is a fixed marginal cost. So from 5 to 10, so each unit, as we increase from 5 to 6, so we have to incur additional 180. Okay, so from 5 to 10, 5 units involved. So 5 multiplied by 180 give us 900. Okay, so 900. Um, so the change in the cost as we increase production from 5 to 10, okay, would be 900. So this is how we do it. You simply substitute 10 and 5 in the original cost function and find the difference. So the increase in the cost correspond to the area of the shaded region under the marginal cost, right? I mean, if you see this, the width is 5 and the height is 180. So 5 multiplied by 180 will also give us 900. So there are two ways how we can measure the change in cost as we increase production from 5 to 10. Either we take total cost 10 units minus total cost 5 units, or we can also use this, find the area. Okay, find the area. So we have already established the relationship that these two are the same. So the total cost of 10 units subtract it minus total cost of 5 units, we can also find the area under the curve, where if we have the curve, right, I mean the cost, the marginal cost is a curve, right? I mean this is C prime f of x. So for be from 5 to 10, right? So we also know that this would equals to finding the area where the height, okay, of the function is 180. Okay, so the change in cost from 5 to 10 is equal to the area between the marginal cost function and the x-axis from 5 to 10. Okay, so that's basically the relationship, okay, that we have established. So let's have a look at this example. So if we have this cost function, so if let's say we want to find the change in cost from 5 to 10, okay, so let's say we want to draw the graph. So this is the graph, okay, and to find the change, we simply plug in the value x equals to 10 and x equals to 5, and then we can subtract them. So you should be able to do this. You put in 10 and then you put in 5. So find the difference between C10 and C5, which would be 962.50. 50 cents. Okay, and then for part B, graph the marginal cost and then use the geometric formula to calculate the area, okay, between the curve, the marginal cost curve and the x-axis. Okay, so the marginal cost here, so if you do the marginal cost, this would be negative, so 7.5 multiplied by 2 is negative 15x plus 305. So 305 is the y-intercept, so this is 305, and the slope is negative, negative 15. So if this would be 5 and this is 10. Okay, so how do we find the area? So this is a trapezoid. Okay, a trapezoid. If you don't remember, so I mean, check back your high school geometry. Okay, and suppose and now we want to compare the results from A and B. Okay, it seems that for both method, we found that the answer is the same. Okay, the answer is the same. So this basically give us theorem 1, which is the fundamental theorem of calculus, says that if we have a function that is continuous on this interval A and B, and the big F is any antiderivative of F, then basically the definite integral of this integrand f of x small f from A to B, lower limit, upper limit, would simply equal to the antiderivative evaluated at the upper limit minus the antiderivative, the big F, evaluated at the lower limit. Okay. So any definite integral of any function can be evaluated whenever we can find the antiderivative and evaluate the antiderivative at the upper limit and the lower limit. Okay. So the antiderivative of a function, okay, like last time we have already said that it differs by at most a constant. So when we use the fundamental theorem, okay, this theorem to evaluate a definite integral, we generally choose the simplest antiderivative by letting the constant to equal to 0. Okay, so we can simply impose this restriction. So when we evaluate the definite integral using this fundamental theorem, it is convenient to use this notation. Okay, this notation. So we have the antiderivative, big F, and then put a vertical line here and put the lower limit A at the bottom and put the upper limit B on top, which represent the change in the antiderivative from A to B, which basically says that this represent the antiderivative evaluated at the upper limit, subtract it with the antiderivative evaluated at the lower limit. Okay, so if we have this example, so step number 1 would be we have to find the antiderivative. So how do we find the antiderivative? Okay, so step number 1, so we simply rewrite, we can apply the whatever properties that we have discussed before, right? So this one we can separate them because this is summation and subtraction. So we deal with them one by one. And then this is constant, this is constant, this is constant, this is constant. So we can take the constant up to the front, and we simply use this one, use the power rule, right? I mean, 2 equals to 2 plus 1 is x to the power of 3 divided by 3. So 3 cancel with 3. So this exponent, we get exponent itself. And then we get, this is 1 over x. So we get 3 multiply, because c is a constant, multiply with the natural log of the absolute value of x plus c. Okay. And we're going to simply, because now we want to evaluate the definite integral from 1 to 3, we're going to impose this restriction where c equals to 0. Are we done yet? Not yet. Okay, because now we need to use, we're going to apply the fundamental theorem of calculus where we're going to use this. Okay, we're going to evaluate this, okay, from the different, when we evaluate this antiderivative at 3 and 1. Okay. So what we need to do, you simply need to replace all these x's with 3, and you should get negative 9.88. And then you substitute x equals 1, and you should get negative 4.44. Be careful with the negative sign here. This is negative, so they become positive. And the final answer would be negative 5.44. Okay, that's it. And sometimes, of course, like what we have discussed previously, you need to use integration by substitution method if, let's say, the integral is not that clear enough. Okay, like in this case, we simply replace the denominator with u, and then the du equals to 2 dx. Okay, so we can rewrite this whole thing. We're going to rewrite this whole thing in, because right now we want to replace dx needs to be multiplied by 2, right? And because of that, we multiply with 1 over 2. So such that we can write 2 inside. Okay, so what we have done from here to here, we simply multiply by 1. Okay, by 2 over 2, which is 1. Okay, and then this term here, the integrand, we can rewrite them in this form, 1 over u, and we have replaced 2 dx with du. And make the calculation easier, and then we can substitute this back. Okay, and then we simply need to evaluate the definite integral from the upper and find the difference, right, from the upper limit and the lower limit from 1 to 0, from 1 to 0. And we have obtained this, so this is the antiderivative from this function. So we simply need to substitute, okay, 1 and 0. So it would be 0.203. Okay. Other example, I'm going to leave this to you, okay, as well as this essay type question. Okay, you just need to collect the necessary information and then find the answer. Okay, so maybe we can do this together. So let's see. So let's say we found that the maintenance cost increased at the rate of 90x squared plus 5,000, where mx is the total accumulated cost of maintenance for x years. So in this case, x represents the number of years. So so the question asks us to write a definite integral that represents the total maintenance cost from the end of the second year to the end of the seventh year. Okay, so what we need to, and then the question asks us to evaluate the integral. So we have two things. We need to basically write this, and then we are asked to evaluate this. Okay, so how do we do this? So this is the integrand. So we simply need to integrate this m of x with respect to x from which year? From second year, from 2 to 7. Okay, so what we need to do is we simply rewrite the whole thing here. 90x squared, so put bracket, plus 5,000 dx. Okay, so here when we want the find the antiderivative, so try to integrate this. So when we integrate this, this becomes let me just put it here. So this would be 2 and 7. We can separate them, right? X squared dx plus 5, sorry, don't forget this, 5,000 dx. And this becomes, this is 90, you can bring it to the front, and this becomes x to the power of 3 divided by 3. 90 divided by 3 would be 30, right? So 30 x to the power of 3 plus, there is no x here, so this is a constant, so we simply add x, okay, divided by 1. And this whole thing, we're going to evaluate them from 2 to 7. So what you need to do, you simply need to substitute 37 square plus 5,000, 7, use the square bracket, minus 32 cube plus 5,000 multiplied by 2. And this should give you the final answer. Okay, how we want to evaluate the integral, which is 29,480. So this would be the total maintenance cost from the year from the second year to the end of the seventh year. Sorry, I made a mistake here. That from the end of the second year means beginning of the third year. So this should be 3. So this should be 3. Okay, not 2. Sorry for the mistake there. It should be 3 because it is from the end of the second year, not the beginning of the second year. The end of the second year means the beginning of the third year. So from year 3, we have year 3, year 4, year 5, year 6, year 7, till the end of the seventh year. So we exclude the second year because we want to know from the end of the second year. So be careful when reading the question so that you won't make the same mistake as me. Okay, so all other example, I'm going to leave this to your own exploration. Example 7 would be also good if you have the time, so please do it. It's not that difficult. You only need to be careful when you do the integral, when you find the antiderivative, and then make sure you plug in the correct value. Okay, so with that, I think we'll end here. And I hope you can use the time to practice a few more questions. And inshallah, we'll continue with other topics. Assalamualaikum warahmatullahi wabarakatuh.